FortiGate I Introduction to FortiGate. In this lesson, you will learn about FortiGate administration basics. This includes how and where FortiGate fits into your existing network architecture. After completing this lesson, you should have the practical skills and knowledge of FortiGate administration fundamentals required to do the following: log into your FortiGate, create administrator accounts, configure basic network settings, and use your FortiGate's GUI or CLI. You'll also be able to set up FortiGate to act as your local network's DNS or DHCP server. Lab exercises can help you to test and reinforce your skills. To start, let's talk about how FortiGate is different from traditional firewalls or other vendors that you may have worked with. From the beginning, FortiGate has been synonymous with unified threat management, a traditional firewall with specialized security devices such as VPN gateways and IPS sensors bundled into one device. FortiGate UTM proved popular with small to medium businesses and enterprises or campuses that have many branch offices. However, for managed security service providers and data centers looking for the best performance, Fortinet's FortiASIC chips and next-generation firewall features have been popular instead. How can FortiGate serve all of these types of networks? In this architecture diagram, you can see how FortiGate platforms add strength without compromising flexibility. Like separate dedicated security devices, FortiGates are still internally modular. In addition, devices add duplication. Sometimes dedication doesn't mean efficiency. If it's overloaded, can one device borrow free RAM from 9 others? Do you want to configure policies, logging, and routing on 10 separate devices? Does 10 times the duplication bring you 10 times the benefit, or is it a hassle? For smaller to mid-sized businesses or enterprise branch offices, UTM is often a superior solution compared to separate dedicated appliances. FortiGate hardware isn't just off the shelf, it's carrier grade. Underneath, most FortiGate models have one or more specialized circuits called ASICs that are engineered by Fortinet. For example, a CP or NP chip handles cryptography and packet forwarding more efficiently. Compared to a single-purpose device with only a CPU, FortiGate can have dramatically better performance. This is especially critical for data centers and carriers where throughput is business critical. The exception? Virtualization platforms. VMware, Citrix Xen, Microsoft, or Oracle VirtualBox have general-purpose vCPUs. But virtualization might be worthwhile due to other benefits, such as distributed computing and cloud-based security. FortiGate is flexible. If all you need is fast firewalling and antivirus, FortiGate won't require you to waste CPU, RAM, and electricity on other features. In each firewall policy, UTM and next-generation firewall modules can be enabled or disabled. Also, you won't pay more to add VPN seat licenses later. What requires a subscription? Only ongoing FortiGuard subscription services. FortiGate cooperates. A preference for open standards instead of proprietary protocols means less vendor lock-in and more choice for system integrators. And as your network grows, FortiGate can leverage other Fortinet products such as FortiSandbox and FortiWeb to distribute processing for deeper security and optimal performance, a total security fabric approach. If you deploy FortiGates as virtualized appliances, not physical, that platform will still be familiar. FortiGate virtual machines, known as VMs, have the same features as a physical FortiGate, except for hardware acceleration. Why? First, Hypervisor's hardware abstraction layer software is made by VMware, Xen, and other hypervisor manufacturers, not by Fortinet. Those other manufacturers don't make Fortinet's proprietary FortiASIC chips. But there is another reason too. The purpose of Hypervisor's generic virtual CPUs and other virtual chips is to abstract the hardware details. That way, all VM guest operating systems can run on a common platform, no matter the different hardware where the hypervisors are installed. Unlike vCPUs or vGPUs that use generic non-optimal RAM and vCPUs for abstraction, FortiASIC chips are, by definition, specialized optimized circuits. Therefore, a virtualized ASIC chip would not have the same performance benefits as a physical ASIC chip. If performance on equivalent hardware is less, you may wonder, why would anyone use a FortiGate VM? In large-scale networks that change rapidly and may have many tenants, equivalent processing power and distribution may be achievable by using larger amounts of cheaper general-purpose hardware. Also, trading some performance for other benefits may be worth it. The owner can benefit strongly from faster network and appliance deployment and teardown. FortiGate VMX and the FortiGate connector for Cisco ACI extend this vision. They are a specialized version of FortiOS and an API that allow you to orchestrate rapid network changes through standards such as OpenStack for software-defined networking. So, FortiGate VM is deployed as a guest VM on the hypervisor. FortiGate VMX is deployed inside a hypervisor's vNetworks between guest VMs. FortiGate connector for Cisco ACI allows ACI to deploy physical or virtual FortiGate VMs for north-south traffic. FortiGuard subscription services give your FortiGate access to 24/7 security updates powered by Fortinet's researchers. Your FortiGate uses FortiGuard in two ways: by periodically requesting packages that contain a new engine and many signatures, and by querying the FDN on an individual URL or hostname. Queries are real-time. That is, FortiGate asks the FDN every time it scans for spam or filtered websites. Also, queries use UDP for transport. They are connectionless, and the protocol is not designed for fault tolerance, but for speed. So, they require that your FortiGate have a reliable internet connection. Download packages like antivirus and IPS, however, aren't that frequent. They use TCP for reliable transport, and their associated FortiGate features continue to function even if FortiGate does not have reliable internet connectivity. Keep in mind, though, that you should still avoid interruptions. If your FortiGate must try repeatedly to download updates, it can't detect new threats during that time. So now you've seen a simplified overview of the software architecture. But what about the network architecture? Where does FortiGate fit in? When you deploy a FortiGate, you can choose on the dashboard between two modes, NAT or transparent. In NAT mode, FortiGate forwards packets based on layer 3, like a router. Each of its logical network interfaces have an IP address. In transparent mode, FortiGate forwards packets at layer 2, like a switch. So, except for the management interface, its interfaces have no IP address. Interfaces can be exceptions to the router versus switch operation mode on an individual basis, however. We'll show these later. What does that mean for your traffic in terms of the 7-layer OSI model? Which operation mode should you choose? NAT mode is the most common choice. In NAT mode, the destination address is the FortiGate's address. Typically, FortiGate will rewrite the destination address and/or port number and source address in the IP network layer into the server's private network address before forwarding the packet. In other words, it will apply NAT and port forwarding. Depending on your presentation and application layer protocols, it might also terminate SSL or TLS sessions so backend servers don't need to decrypt, and modify the addresses in the application layer headers, such as the host and x-forward4 addresses in the HTTP header. So NAT mode works well for edge or gateway security, where you divide your private IPv4 network from an external network, such as a guest Wi-Fi or the internet. In transparent mode, the destination address is the server's address, not a FortiGate's interface. As a result, it usually doesn't need to rewrite encapsulated layers, with the exception of TCP SYN-related analysis. Only the MAC address in the frame is rewritten. So in complex IP environments, such as MSSP or mobile phone carriers, this simplifies deployment. Only the management interface needs an IP address. But because network-facing interfaces don't have an IP address, you must verify that your topology doesn't have any loops at layer 2, Ethernet. NAT mode is the default operation mode. What are the other default settings? Once you've removed your FortiGate from its box, what do you do next? Let's take a look at how you set up a FortiGate. Attach your computer's network cable to port 1 or the internal switch ports, depending on your model, to begin setup. In most of the low-end models, there is a DHCP server on that interface, so if your computer's network settings have DHCP enabled, your computer should automatically get an IP, and you can begin setup quickly. To access the GUI on FortiGate or FortiWi-Fi, open a web browser and go to http URL 192.168.1.99. Remember, the default login is publicly available knowledge. Never leave the default password blank. Your network is only as secure as your FortiGate's admin account. Before you connect your FortiGate to your overall network, you should set a complex password. You should also restrict it so that FortiGate allows administrative connections only from your local console or management subnet. What happens if you forget the password for your admin account or a hostile employee changes it? This recovery method is available on all FortiGate devices and even some non-FortiGate devices like FortiMail. It's a temporary account only available through the local console port and only after a hard reboot, disrupting power by unplugging or switching off the power, then restoring it. FortiGate must be physically shut off, then turned back on, not simply rebooted through the CLI. That's the difference between a hard boot and a soft boot. Even then, the maintainer login will only be available for login for about 30 seconds after the boot completes. If you can't ensure physical security or have compliance requirements, you can disable the maintainer account. Use caution. If you disable maintainer and then lose your admin password, you cannot recover access to your FortiGate. All FortiGate models have a console port. This provides CLI access without a network. On older models, it's a serial port. A standard null modem cable can be used to connect the serial port to your computer's serial port. On newer models, it's an RJ45 port. Access by connecting an RJ45 to serial cable from your computer's serial port to the RJ45 port on the FortiGate. In some newer models, the console port is a USB 2 port. In that case, you'll plug in the USB cable, then open FortiExplorer. Each device ships with its appropriate cable. Serial ports on computers are becoming less common. If your computer has one, you can purchase a USB to serial adapter. Most features are available in both the GUI and CLI, but there are a few exceptions. For example, reports can't be viewed in the CLI. Also, the rarely used advanced settings and diagnostic commands for power users are usually not available in the GUI. What if you don't want to use the GUI? There is also a CLI. As you become more familiar with FortiGate, and especially if you want to script its configuration, you may want to use the CLI in addition to the GUI. You can access the CLI through either the JavaScript widget in the GUI named CLI Console, or through a terminal emulator such as Terraterm or PuTTY. Your terminal emulator can connect through the network, SSH or Telnet, or the local console port. SNMP and some other administrative protocols are also supported, but they are read-only. They can't be used for basic setup. Let's focus on that setup now. Whichever method you use, start by logging in as admin. Begin by creating accounts for other administrators. It's not shown here, but instead of creating accounts on FortiGate itself, you could configure FortiGate to query a remote authentication server. You could also require personal certificates authenticated through your PKI certificate authority instead of passwords. Choose strong, complex passwords. For example, you could use multiple interleaved words with varying capitalization and randomly insert numbers and punctuation. Do not use short passwords or passwords that contain names, dates, or words that exist in any dictionary. These will be very weak against brute force attacks. To audit the strength of your passwords, use tools such as LoftCrack or John the Ripper. Risk of attackers brute forcing your firewall is especially high if you connect the management port to the internet. In order to restrict access to specific features, you can assign permissions. When assigning permissions in an access profile, you can specify read and write, read only, or no access to each area. By default, there is a special profile named Super Admin, which is used by the account named Admin. It cannot be changed. It provides full access to everything, making the admin account similar to a root superuser account. The Prof Admin is another default profile. It also provides full access, but unlike Super Admin, it only applies to its virtual domain, not the global settings of the FortiGate. Also, its permissions can be changed. You aren't required to use a default profile. You could, for example, create a profile named Auditor Access with read-only permissions. Restricting a person's permissions to those necessary for his or her job is a good best practice, because even if that account is compromised, the compromise is not complete. To do this, create administrative access profiles, then select the appropriate profile when configuring an account. What are the effects of access profiles? It's actually more than just read or write access. Depending on the type of access profile that you assign, each administrator may not be able to access the entire FortiGate. For example, you could configure an account that can only view log messages. Administrators may not be able to access global settings outside of their assigned virtual domain either. Virtual domains, known as VDOMs, are a way of subdividing the resources and configurations on a single FortiGate. VDOMs are explained in more detail in the FortiGate II Virtual Domains lesson. Administrators with a smaller scope of permissions cannot create or even view accounts with more permissions. So, for example, an administrator using the Prof Admin or a custom profile cannot see or reset the password of accounts that use the Super Admin profile. To further secure access to your network security, use two-factor authentication. Two-factor authentication just means that instead of using only one method to verify your identity, typically a password or personal certificate, you can verify identity in two ways. In the example shown here, two-factor authentication would mean a password plus an RSA randomly generated number from a FortiToken that is synchronized with FortiGate. FortiToken is not the only option if you want to use two-factor authentication. Remember, two-factor only means that you use two methods to verify a person's identity. Alternatively, instead of using FortiToken, FortiGate can send an email to the administrator's address or send a text message as a form of authentication. To be able to do this, you must first configure FortiGate with the settings of a mail server so that it can use it to send email, or an SMS server. The mail server can be configured under the Advanced page in the GUI or in the CLI. SMS settings, however, are CLI only. Another way to secure your FortiGate is to define which hosts or subnets are trusted sources of login attempts. Define all three for all accounts. If you leave any IPv4 address as 0.0.0.0/0, it means that connections from any source IP will be allowed, obviously not what you want. Notice that each account can define its management host or subnet differently. This is especially useful if you will be setting up VDOMs on your FortiGate, where the VDOM's administrators may not even belong to the same organization. Now try to access FortiGate's GUI or CLI from an external IP. Does it work? No. If your connection is coming from an IP address that is not listed as trusted in any of the admin accounts, the FortiGate will not reply. Your browser connection will time out. You may also want to customize the administrative protocol's port numbers. You can also choose whether to allow concurrent sessions. This can be used to prevent accidentally overwriting settings. If you usually keep multiple browser tabs open, or accidentally leave a CLI session open without saving the settings, then begin a GUI session and accidentally edit the same settings differently. For better security, use only secure protocols and enforce password complexity and changes. We've defined the management subnet, that is, the trusted host, for each administrator account. How do you enable or disable management protocols? This is specific to each interface. For example, if your administrators connect to FortiGate only from port 1, you should disable all administrative access on all other ports. This prevents brute force attempts and also insecure access. Notice that some protocols like FortiTelemetry are not actually for administrative access, but, like GUI and CLI access, they are protocols where the packets will have FortiGate as a destination IP, not only use FortiGate as the next hop or bridge. For better security, it's always best to only use secure, encrypted methods of access. Some protocols, such as Telnet, ICMP, HTTP, and SNMP version 1, don't have encryption or even authentication, so they should never be enabled on public, untrusted networks. IPv4 and IPv6 protocols are separate. It's possible, for example, to have both IPv4 and IPv6 addresses on an interface, but only respond to pings on IPv6. However, IPv6 is hidden in the GUI by default. How do you show IPv6 settings? FortiGate has hundreds of features. If you don't use all of them, hiding features that you don't use makes it easier to focus on your work. Hiding a feature in the GUI does not disable it. It is still functional and still can be configured through the CLI. Some advanced or less commonly used features, such as IPv6, are hidden by default. To show hidden features, go to the Feature Select page. Link aggregation is when multiple physical interfaces are logically bound into a single channel. Link aggregation increases bandwidth and provides redundancy between two network devices. Once you have administrator accounts, they can configure the network interfaces. Remember, when the FortiGate device is in NAT mode, every interface that handles traffic must have an IP address. There are two exceptions to this rule, which we will cover next. When in NAT mode, the IP address allows packets with this interface to have a source and destination at the IP layer. There are multiple ways to get an IP address: manual or automatic, using either DHCP or PPPoE. PPPoE is configured through the CLI. As we mentioned earlier, there are two exceptions to the IP address requirement: one-arm sniffer and dedicate to FortiSwitch interfaces. These interfaces aren't assigned an address. When one-arm sniffer is selected as the addressing mode, it operates in promiscuous mode. As a result, regardless of each packet's destination address, FortiGate can expect all traffic that arrives. So, although the overall FortiGate is in NAT mode, acting as a router, the one-arm sniffer interfaces does not act as a router. It receives traffic but cannot send. There are more considerations, which are in the FortiGate II Intrusion Prevention System lesson. When dedicated to FortiSwitch is selected as the addressing mode, FortiGate automatically assigns an IP address to this interface. The dedicated to FortiSwitch is an interface setting that is used to manage FortiSwitch from the FortiGate. How many times have you seen network issues caused by a DHCP server, not client, enabled on the WAN interface? Beginning in FortiOS 5.4.0, you can configure the interface's role. Roles show only normal interface settings for that part of a topology. Settings that do not apply to the current role are hidden. This prevents accidental misconfiguration. For example, when the role is configured as WAN, there is no DHCP server, device detection, and secondary IP address configuration available. Device detection is usually used to detect devices internally on your LAN. That is, you won't offer IP addresses to all hosts on the internet, and so on. If there is an unusual case, and you need to use an option that's hidden by the current role, you can always switch the role to undefined. This displays all options. To help you remember the use of each interface, you can give them aliases. For example, you could call port 3 Lab Network. This can help to make your list of policies easier to comprehend. Wireless clients aren't the only ones that can use FortiGate as their DHCP server. For an interface, such as port 3, select the Manual option, enter a static IP, and then enable the DHCP server option. Options for the built-in DHCP server will appear, including provisioning features such as DHCP options and MAC reservation. You can also block specific MAC addresses as if they were a Layer 2 firewall policy. For the built-in DHCP server, you can reserve specific IP addresses for devices with specific MAC addresses. Those devices will always receive the same lease unless the number of devices exceeds the size of the IP pool. Like with DHCP, you can also configure FortiGate to act as your local DNS server. You can enable and configure DNS separately on each interface. A local DNS server can improve performance for your FortiMail or other devices that use DNS queries frequently. If your FortiGate offers DHCP to your local network, DHCP can be used to configure those hosts to use FortiGate as both the gateway and DNS server. FortiGate can answer DNS queries in one of three ways. By relaying all queries, that is, acting as a DNS relay instead of a DNS server. By relaying only the queries it can't resolve to your IPS's DNS server, or by returning a null response if it can't resolve queries itself. Beginning with FortiOS 5.4, you can configure all modes in the GUI without using the CLI. If you choose the DNS forwarding option, you can control DNS queries within your own network without having to enter any DNS names in FortiGate's DNS server. If you choose to have your DNS server resolve queries, or you choose a split DNS, you must set up a DNS database on your FortiGate. This defines the host names that FortiGate will resolve queries for. Use the zone file syntax outlined by RFCs 1034 and 1035. Lastly, before you can integrate FortiGate into your network, FortiGate must have a default gateway. If FortiGate gets its IP address through a dynamic method, such as DHCP or PPPoE, then it will also retrieve the default gateway. Otherwise, you must configure a static route. Without this, FortiGate will not be able to respond to packets outside the subnets directly attached to its own interfaces. It probably also won't be able to connect to FortiGuard for updates, and may not properly route traffic. Routing details are covered in another lesson. For now, you should usually make sure that FortiGate has a route that matches all packets and forwards them through to the network interface that is connected to the Internet, to the IP address of the next router. Routing completes the basic network settings that are required before you can configure firewall policies. Now that FortiGate has basic network settings and administrative accounts, let's look at how to back up the configuration. You can encrypt configuration files with a password if necessary. Besides securing the privacy of your configuration, it also has some effects you may not expect. Once encrypted, the configuration file cannot be decrypted without the password and a FortiGate of the same model and firmware. This means that if you send an encrypted configuration file to Fortinet technical support, even if you give them the password, they still cannot load your configuration until they get access to the same model of FortiGate. This can cause unnecessary delays when resolving your ticket. Even if the configuration is not encrypted as a whole, each password is encrypted individually, so in many cases, encrypting the entire configuration file may not be necessary. If you enable virtual domains, subdividing the resources and configuration of your FortiGate, each VDOM administrator can back up and restore their own configurations. You don't have to back up the entire FortiGate configuration. If you open the configuration file in a text editor, you'll see that both encrypted and unencrypted configuration files contain a clear text header that contains some basic information about the device. The diagram shown here shows what information is included. To restore an encrypted configuration, you must upload it to the same model of FortiGate with the same firmware version, then provide the password. To restore an unencrypted configuration file, you are only required to match the FortiGate model. If the firmware is different, FortiGate will attempt to upgrade the configuration, similar to how it uses upgrade scripts on the existing configuration when upgrading firmware. Usually, the configuration file only contains non-default settings, plus a few default yet crucial settings. This minimizes the size of the backup, which could otherwise be several megabytes in size. Upgrading the firmware on a FortiGate is simple. The easiest method is to click the Update link on the System Information widget on the dashboard, then choose a firmware file that you have downloaded from support.fortinet.com. If you want to make a clean install by overwriting both the existing firmware and its configuration, you can do this using the local console CLI within the bootloader menu while FortiGate is rebooting. However, this is not the usual method. You can also downgrade the firmware. Since settings change in each firmware version, you should have a configuration file in the syntax that is compatible with the firmware. Remember to read the release notes. Sometimes a downgrade between firmware versions that preserves the configuration is not possible, such as when the OS changed from 32-bit to 64-bit. In that situation, the only way to downgrade is to format the disk, then reinstall. Once you've determined the downgrade is possible, verify everything again, then start the downgrade. After the downgrade completes, restore a configuration backup that is compatible with that version. Why should you keep emergency firmware and physical access? Old firmware versions don't know how to convert future configurations. Also, when upgrading through a path that is not supported by the configuration translation scripts, you might lose all settings except basic access settings, such as administrator accounts and network interface IP addresses. Another rare but possible scenario is that the firmware could be corrupted when you are uploading it. For all of those reasons, you should always have local console access during an upgrade in case of emergency. However, in practice, if you read the release notes and have a reliable connection to the GUI or CLI, it should not usually be necessary. To review, these are the topics that we just talked about. We looked at how FortiGate can replace multiple single-purpose devices, yet increase power efficiency and throughput. We explained the differences between FortiGuard services and how those are part of the UTM architecture. We showed how to configure administrator accounts, permissions, and how to harden administrative access. We also explained how to choose the operation mode based upon the behavior you need for each network interface, how to configure the network settings, and finally, how to back up the configuration and install firmware.